Hello viewers, welcome back to my channel. Today in this video I am discussing symmetric and skew symmetric matrices, some important results for symmetric and skew symmetric matrices. These topics are most important for any mathematics exam, that is IIT JAM, engineering mathematics, MSc entrance and CSR NetCase. Many entrance exams, these topics are most important. Symmetric and skew symmetric matrices. These matrices we called as a special type of matrices. These type of matrices we called as a special type of matrices. First we examine the symmetric matrices. What is symmetric matrix? A is symmetric. A is symmetric matrix if and only if A transpose is equal to A. This is the definition of symmetric matrix. How to write the general form of symmetric matrix? Now we have to examine the general form of symmetric matrix. We consider any 2 by 2 matrix, that is A, B, C, D, and we take A transpose is equal to A, that is A, B, C, D. Whole transpose is equal to A, B, C, D. Then what is the transpose of this? A, B and C, D. This is we get this is equal to A, B, C, D. Now we observe that C, if BC is equal to C, that is BC is equal to C. Here observe that this element BC is equal to B, and here C, B is equal to C, and diagonal elements are same, AD, AD. Okay, that means this implies BC is equal to C. That means in 3 by 3 matrix we write down diagonal elements. All the diagonal elements we take any real numbers, diagonal elements A, B, C, D, but we see this what this we take here, suppose we take here X, what we are written same as it is here, copy it. We are written Y, same here copy, and Z, sorry, this is C, diagonal element. Here we come, what here written Z, same here as it is copy. This is the general form of the symmetric matrix. This is the general form of matrix. All the diagonals are real, but we have to observe that this element and this element, this element, what are the elements here come, same these elements come here also. If suppose we write down one line to diagonal line, we take one line to diagonal elements, half of the diagonal below, what are the elements are there in above diagonal line, the same elements come into same elements come here also. Okay, that type of matrix we call as symmetric matrix. We take here one, suppose we are one object is there, same object come here also, means diagonal line act as a mirror, like a mirror. We take a mirror, suppose we take one example, A, C, D, E, A, B, C, H, I, J, K, L, here D, here J. We suppose we take, see this, we take one line to diagonal line. See this, C is there, the diagonal line act as a mirror, like a mirror. C elements come same as here also, D also come here same, J come here also J come. This is the example per symmetry. Now we have to examine the skew symmetric matrix. Skew symmetric matrices. That means if A is skew symmetric matrix, if and only if A transpose is equal to minus A. This is the skew symmetric. We take one 2 by 2 matrix, example A, B, C, D, whole transpose is equal to minus of A, B, C, D, and A transpose of this is A, B, C, D, whole transpose is equal to minus A, minus B, minus C, minus D, and A is equal to, A is equal to minus A, and C is equal to minus B, and what is b is equal to minus c, and d is equal to minus d. And here observe that these are same. If um, and we return like this also. If here a plus a is equal to 0 and a is equal to 2a is equal to 0, a is equal to 0, and same here also d is equal to 0. That means if a b c d, that means if a b c d is equal to, that means you take one this matrix, the diagonal elements are zeros, and if they here one elements come b, the opposite elements is comes as a minus b. Okay, if these elements come c, if the opposite elements come as a minus c, negative of that element. Okay, always we take one note, that is the skew symmetric matrix diagonal elements always 0. This is important note. In a skew symmetric matrix, diagonal elements always 0, always 0. This is the important note for skew symmetric matrix. Now we have to see some examples for skew symmetric matrix. These are the some few examples for symmetric and skew symmetric. This is a question: which of the following are symmetric and skew symmetric, and none of these? See this first example: 0 minus 1 b minus 1 0 a b a 0 is the given. See this observe that this element diagonal elements is, if these if suppose this is skew symmetric, then this opposite elements, if these elements is minus 1, this opposite comes as 1 only, but here come as minus 1. That means this has symmetric matrix. B is same as here, B also, A here also same. We take image here, mirror, take diagonal, we take as mirror. These up what are the elements here come, same these elements come here also. That means this is symmetric. Diagonal elements we take any real, 0, anything, but in case of symmetric skew symmetric only, diagonal elements are must and should. And if these are one element come here, opposite element negative of that element. Okay, we see this element, we take mirror, diagonal as mirror, minus 1 minus 1 b b a, this also symmetric, and this also symmetric. We observe that this is b, all the elements are 0, all the diagonal elements are 0, and there is a possibility of skew symmetrics. Check it, 1 is there, minus 1. Okay, b is there, negative of minus b, and a is there, negative of minus a. Therefore this is 100% skew symmetric. And see this, we take mirror, 1 is there, minus 1 there, b is there, minus b there, a is there, and minus a there. But that means this is not symmetric as well as skew symmetric, because if symmetric, all the diagonal elements are 0, but here there is no, these all the diagonal elements are 1 1 1, there is no zeros, and 1 is minus 1 there. We carefully observe, if all the diagonal elements are 0, and as well as these element, if above these elements or below these elements, the image was negative of that element. Okay, if minus 1 is there, minus 1, if all the diagonals were 0 0, that this matrix 100% skew symmetric. But here 1 1 1 is there diagonal, that's why this is not symmetric as well as skew symmetric. Why not symmetric means here 1 is there, minus 1, how it is possible? Okay, that's why this is not symmetric as well as skew symmetric. That means this is none of this. Okay, and the one of the result is this is the one of the important note. If a is equal to sum of symmetric plus skew symmetric, observe that this is one of the important note. If they given one matrix, that means if the matrix is sum of symmetric and skew symmetric, if a plus a transpose by 2 plus a minus a transpose by 2, This is the symmetric part and skew symmetric, but if you solve this equation we get again a only. uh, these are the some important results and examples for symmetric and skew symmetric. Thanks for watching. If you like this video, please like, share and subscribe my channel. Thank you.